Hi, and welcome to my video on the review of the change rule. And as in all previous reviews, you can treat the review as a quiz where you can give yourself a mark or score for each question. You total up the page and you get a score at the bottom. And then when you're finished, total up all the pages and you get a mark out of 30. Here we go. Find each, and this is f of the g of x is a composite function. So when we're doing the chain rule, we have an inner function and an outer function. So the inner function is the g of x, the outer function is the f of x. So in this one, y equals bracket e to the x plus 2 cubed. The inner function is the outer function is x cubed, and the inner one is what's on the inside is e to the x plus 2. So when you do composite, the g goes in here, so that makes this the inner, and that's the outer. So give yourself a mark each, so that's 2 marks for that one, if you get both of these right. And on this one, the outer one is the sine of x, and the inner one is 6x. Again, if you get both of these, give yourself 2 marks. That's a total of 4. Number 2, find the d of x of each. So this is the derivative of the ln, but again, the difference is that we're using chain rule because we have an inner and an outer. So if we do the derivative, the d dx of this, so we have ln of, we do the derivative of the whole function times the derivative of the inner. So that's 3 and that's 3. So the derivative of the ln, so it's the derivative of all of it, and the derivative of the inner. So the derivative of ln is 1 over 6x squared minus 3x, and the derivative of this polynomial, 6 times 2 is 12, so that gives us 12. X is the exponent decreased by 1, so it's 12x, and the derivative of 3x is 3. And we simplify that, so we have a 12x minus 3 all over 6x squared minus 3x. And we notice that 3 is a factor here and x is a factor here, so we factor that, we get 3 outside of 4x minus 1. And here we get 3x outside of, and that's 2x minus 1. And the 3 cancels because they're common factors, so we get 4x minus 1 all over x times 2x minus 1. And it's 3 marks for this. So if you did this step right, you got a mark. If you did this derivatives right, you got a mark. And if you simplify by removing the x common factor, you get those 3 marks. And we do on the cos. So notice this is a power. So this is really, if you think about it, that's the cos of 5x to the 4th power. So there's a power rule here. So the derivative here, the derivative of the whole function is cos of 5x, make that an x. It's the derivative of the whole function and the derivative of the inner, which is the cos of 5x. And again, we have an inner again, so we have to do the derivative of 5x. We keep doing the derivative until we get right to the inside, which is 5x. So this is the power rule, so this is 4 cos 5x, and so that's a 3, and the derivative of cos of 5x is negative sine 5x, and the derivative of 5x is 5. So if you simplify that, you get a negative. 4 times 5 is 20 negative, and we get cos. If you want to put the 3 here, you can, or you can leave it the 3 as a power, and that's sine 5x. Again, 3 marks. So if you have this step as showing the derivatives of the inners and outers. Give yourself a mark. If you did the derivative correctly, a mark. And if you did the final simplification, give yourself marks. So 3 marks altogether. So we have 2 to the tan x. Again, we have the whole function. So it's the derivative of 2 to the tan, 2 raised to the tan x derivative, and the derivative of the inner, the derivative of the tan of x. And the derivative of 2 to the tan x is 2 to the tan x and ln of the base, the ln of 2. And the derivative of tan is secant squared x. And so if you have this step right here marked, we have this one done correctly and marked, so that's 2. So that's 12 for that page, 12 in total. And let's continue. Again, we're doing a review. So I'm going to review all the ideas that I did with the chain rule. So just doing more examples. Number 3, if y equals secant of 6x minus 9 and the ln of 3x, find dy dx. Well, dy dx is on this function is the d dx on the y, and it's the d dx on all of this, which is secant of 6x minus 9 ln 3x. So I just showed you d dx. So the d dx on the y is dy dx, and the derivative of this function so is d dx. So we treat this as a product. This is f and g. So if you think about it, f times g derivative is derivative of f times g plus f times the derivative of g. So this is the f, so it's the secant of 6x minus 9. So derivative of that times g, which is ln 3x, plus we have the secant of 6x minus 9, and we have the ln of 3x derivative. So that's derivative of f times g and f times the derivative of g. So that comes down to be, this is the derivative of secant. So that's the outside function. So that's the derivative of secant times the inside, which is 6x minus 9, and the ln of 3x. Now I could have done this faster, but I wanted to show you. So this is the secant of 6x minus 9, and so this is the ln of 3x derivative times, and this is inside derivative of the inside. So everything is going okay. So again, this is a chain rule. Derivative of secant is the outs, the whole thing times the derivative of the inside. So right here, I didn't put the derivative of the inside right there. I did derivative of ln 3x and the derivative of the 3x. So again, we're doing a derivative of the whole plus the derivative of the inside. So the derivative of secant 6x minus 9 is tan of 6x minus 9, and secant of 6x minus 9, when you got this memorized, and the derivative of this polynomial is just 6. Derivative of 6x is 6, derivative of a constant is 0, plus secant of 6x minus 9. Derivative of ln of 3x is 1 over 3x, and the derivative of 3x is 3. So when we simplify this, let's see what we have. We have tan 6x. Oh, we could put a 6 in the front of here if we want to. Oh, what I did here too, I forgot to put the ln of 3x there. So I was concentrating on the derivative of secant, which is tan secant, the derivative of the polynomial, is a 6, and I forgot to put ln of 6. So that's 6 is outside, secant, 6x minus 9, and ln 3x. So you can't simplify that, only put the constant of 6 in the front. And the 3 cancels out here, so I get, you could say, 1 over x secant of 6x minus 9. So there's 5 marks for this, so let's put the 5 marks. If we did this and recognize that it was, we get a mark, we have a product. So if we did this step, so almost as I do it, almost a step, a mark for each of these steps. So that's 5 marks in total. Hopefully everything is going okay. And again, chain rule is very important. And number 4, if the f of x is equal to sine of 3x over the cos of 4x, find the f prime of pi over 2. So let's do the derivative first. This is f prime, and again this is an f and a g, so the derivative of an f over g prime, the derivative is f prime times g minus f g prime all over g squared. So this is f and g, so the derivative of f prime, let's do f of x first, derivative, and then we'll put the pi over 2 in after. So the derivative is, we have f prime, so that's the sine 3x derivative, times g, which is the cos of 4x, subtract f, which is the sine of 3x, and we do the cos of 4x derivative. All over, it's the cos of 4x being squared. So let's do the derivative of the sine of 3x. Again, we got a chain rule here. The derivative of sine is cos, so that's the cos of 3x and times 3. So that's the whole, if I put a 3 here, you could multiply the 3 by 3x to get 9, but not. It's the cos of 3x times 3. So that's why I'm putting a bracket around both of these to indicate that. And this is the cos of 4x minus the sine of 3x, and the derivative of cos of 4x is negative sine 4x, and notice I'm doing it all at one time now and not writing out the prime, so the derivative of 4x is a 4. So I could put a prime on, I have the prime here, but I just did derivative of this chain right here, and I did derivative of this here without writing it down, just doing a little shortcut. So this is the cos of 4x being squared. So that gives us, if you simplify that, that gives us 3 is a constant, so 3 cos 3x cos 4x, and a negative times a negative positive, so we got a 4 positive 4 sine 3x sine 4x, and that's all over cos of 4x being squared. Again, I can put this 2 here to indicate the power of cos, or I can leave it here. Now, what about f prime of pi over 2? So let me put the pi over 2 in, and we'll get the derivative. So we'll go 3 cos, so I'm putting pi over 2 in the place of x, just taking my time, because it's so easy to make an error. Now I could take a shortcut and without putting it in and just but I'm writing it down just to make sure it's explained. So we have 3. So 3 times pi over 2 is the cos of 3 pi over 2. And cos 4 times pi over 2, 2 into 4 goes 2, so that's 2 pi, plus, and right here we should have the sine the same as here, so that's a 3 pi over 2, and this 4 times pi over 2 is the same as here, so that should be a 2 pi. And again, do the bottom, so that's cos 4 times pi over 2 is 2 pi, and we have a square. So now what we need the unit circle in terms of pi. But before we do that, 3 pi over 2 is the same as pi is 180, so that's a 3 times a 90, so that's a 270. And 2 pi is 2 times 100, pi is 180, so that's 2 times 180, so that's 360. So if we go to the unit circle, whose radius is 1, we have 1, 0, we have 0, 1, we have negative 1, 0, and we have 0, negative 1. So let's go through and look at 3, the cos of 3 pi over 2. That 3 pi over 2 is 270. Cos is the x, so the x is a 0. The cos of 2 pi is the cos of 360. 360 is all the way around here. Again, cos is the x, so we have a 1. And 4, and now we have the sine of 270. 270 is right here, and the sine is the y, so that's negative 1. And the sine of 2 pi is 360 all the way around. Sine is the y, so we got a 0. And we have 2 pi again. 2 pi is here, all the way around 360. Cos is 1, so that's a 1 squared. Simplify that. 3 times 0 times 1 is 0, plus 4 times negative 1 times 0 is 0. 1 squared is 1, so that's 0 over 1, which is 0. So the derivative is the slope of the tangent. So that's why we work this out. The derivative at pi over 2 is 0, so the slope of the tangent is 0. If the slope of the tangent is 0 as the horizontal line, so we're really looking at the horizontal line going through whatever point the value of this point is going to be. So it's going to be a horizontal line going through a point. So if I plug pi over 2 in here, I will get a point, and at that point I'll have a horizontal line. So that's 7 marks there. So the 7 marks, if almost each of these steps is a mark. So we have a 1, a 2, a 3, and we sub those in. We have a 4, and we have a 5, and we have a 6, and down to a 7. So 7 marks altogether. Again, this is a horizontal line. The slope is 0. So if I take pi over 2 and sub it in here and work out, I'll get the point that we have a horizontal line at. And you can do that yourself. I just don't want to make the video too long. Number 5. Find the equation of the normal line to y equals x plus 2, x squared plus 4x plus 2 all to the 4th power. And we want to find the equation of the normal line at x equals negative 1. So the equation of a line is y equals mx plus b is the one I'm going to look for. So we need a slope and we need a y-intercept. So to do that, I will get a point, and then I'll get my slope by doing the derivative, and then I'll plug my slope and the point in the equation of the line and find the y-intercept. But remember, a normal line is perpendicular to a tangent, and the derivative is the slope of the tangent. And so we'll find the slope of the tangent first and get the slope of the normal. And the slope of the normal is perpendicular, the normal is perpendicular to the tangent. So the slope of the normal is the negative reciprocal of the slope of the tangent. So let's proceed to find what point. So what point we're looking at? So we're looking at the point when x is negative 1. So y equals x squared plus 4x plus 2 to the fourth power. And we're plugging in negative 1 in the place of x. So we just take our time, and we get negative 1 squared is 1. Negative 4 times negative 1 is negative 4. And that gives us negative 1 to the fourth power, which is a 1. So the point that we have, x is negative 1 and y is 1. So we found a point. Now we're going to get the slope of the tangent. Again, the normal is perpendicular to the tangent, negative reciprocal of the slope of the tangent. So the slope of the tangent, is the derivative. So we're looking for the slope of the tangent of the derivative, so we get y prime. So what we have here is to get the y prime on this function. We look up here. Again, the function is y equals bracket x squared plus 4x plus 2 all to the fourth power. So the derivative of y prime of this function is that we have a power. So we have y prime is the derivative of the whole function with the power rule. So we get the derivative of the whole function, here we are, plus the derivative of the inside, because we've got to do the chain rule. And so the derivative, power rule, 4 goes in front, and the 4 decreases by 1 to become a 3. And the derivative of this polynomial, derivative of x squared is 2x, derivative of 4x is 4, derivative of 2 is 0. So now I could multiply it out, but I don't need to, because I'm looking for the slope of the tangent at x equals negative 1. So I'm just going to sub a negative 1 in here, and I get 4, and take your time, I get negative 1 squared, 4 negative 1 plus 2 cubed, and I get 2 negative 1 plus 4. So we take our time and work this out, but we already know what this one is, because we got this is right here, so that works out to be negative 1. And the inside of here, that's negative 2 plus 4, that's a 2. So that's 4. Negative 1 cubed, we got to do the power first by PEMDAS. Negative 1 cubed is negative 1. So that gives us a negative 8. So that means that y prime is negative 8. That means the slope of the tangent is negative 8. So the slope of the normal is perpendicular, negative reciprocal of that, because normal and tangent are perpendicular. So the opposite of a negative is positive, so the positive reciprocal of 8 is 1 over 8. So that's the slope of the normal. And so that's the slope of the normal, and the point we came up with negative 1, 1. So if we sub that into y equals mx plus b, this is x and this is y. Y is 1, the slope is 1/8. The x is -1, and we'll get our y-intercept. 1 equals -1/8 plus b. And I'll leave my b there and move my 1/8 over, make it positive. So 1 is the same as 8/8. So my y-intercept is 9/8. So the equation of my normal, is y equals mx plus b. So y equals, the slope of my normal is 1/8, and my y-intercept is 9/8. So that's the equation of my normal to this function with the fourth power. And there's 6 marks here. So if I were giving the marks, I just give them, I give one here, and I give another one here, and I give another one here, and the negative reciprocal, and worked out my y-intercept, and there's the equation. So 6 marks altogether. And that brings, I have no more to do. That's the last question on this review. So what you do, you total up all your page, and you go to the first sheet and put your score over 30, divide 30 into your numerator, get a decimal, move your decimal 2 places to the right. Or you could take your fraction, multiply by 100, and you get your percent. So that brings us to the end of the unit on the chain rule. So I hope my videos can help you understand how the chain rule is used and how it comes around. And if you do, again, as in all video, click on my like button, click on my subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.